Hello viewers on YouTube. In this video tutorial, we are going to consider the compound angle formula, which is also sometimes referred to as the addition formula. This is one of the very important formula in trigonometry that plays a very crucial role in the concept entirely. So the first thing first is for you to be familiar with these formulas. They have a proof actually, but that won't be in this video. The main purpose of this video is to show you how to use this formula effectively to solve problems involving trigonometry. So what says the first one? It says that the sine of the sum of two angles A plus B, either they are acute or obtuse, regardless, the formula still works fine. So this is equal to the sine of the first one times the cosine of the second angle, then plus the cosine of the first one times the sine of the second angle. So this formula is very straightforward to understand. You need not to cram it. All you need to know is that when the sign between the two angles is positive, then you are associating positive at the right hand side, and you just need to use the sine function and the cosine function to expand the two angles, where the first one will be starting with sine, the second one will be for the cosine, and you repeat it in the vice versa. So what about if the sign between the two angles is negative? What would happen? Well, the good news is that the result is the same. The only thing that distinguishes them is the sign that connects them again at the right hand side. So this time around, instead of positive, it will now be negative. So minus cosine A sine B. So this simply means that once you know one of them, you know the other one. Now, what if it is cosine instead of the sine? If it is cosine A plus B, this is equal to the cosine of A times the cosine of B, then minus the sine of A times the sine of B. Notice the difference between the expression when it is sine and when it is cosine. Keep that in mind. And the cosine when the sign between the two angles is negative, the result will be the same as this, or the sign will flip. It will also change. Cosine B, then instead of subtraction, it will now be positive. Sine A, sine B. So that's for cosine A minus B. And for tan A plus B, that's equals to tan A plus tan B, then divided by, I don't want it to occupy space because I'm still going to write, okay, let me just do it like that. Then you'll be the one to have tan A minus B copied down in your notes. That'll be 1 minus tan A tan B. So when it is negative, when it is tan A minus tan B, the only thing that will change is that here will now be negative and here will now be positive. So that is the formulas of trigonometry called addition formula or compound angle formula. Now the next thing is for you to know how problem can come involving the use of this formula and how you can approach them effectively. So for this to work fine, let's try to go over some of this problem. Example number 1. Evaluate without using table the sine of 75, cosine of 75, sine of 75, and sine of 120 minus 45. If you know what to do already, feel free to pause the video and figure this out yourself. So let's begin. Let's begin with number 1, which is the sine of 75. You might be wondering, how do you want to approach this in the first place? Well, all you need to do is to break this 75 into two smaller angles. And make sure that the angles we're breaking them into, they have to be special angles, because you are solving this without calculator or table. Now, notice that 75 can be pieces into two smaller ones by just adding 45 and 30. And it's obvious that 45 and 30 are special angles. So we are good to go. So that will be your first step. So this is the same as sine of 45 plus 30. Now you can assume this is your angle A and this is your angle B, and then apply the formula that we discussed earlier to simplify it. So therefore, sine 45 plus 30 becomes the sine of 45 times the cosine of 30. Since the sign is positive, we are still using positive at the right hand side, plus the cosine of 45 times the sine of 30. Now, if you don't know the corresponding values for the trigonometric functions of special angles, then I'll leave the link in the description. I have a video already that tells you, or that explains how you can know the value for the trigonometric function of any special angle, either 45, 30, or 60. So feel free to check it out, and then after that you can continue with this video so everything can work fine. But let me just give you a brief intro. Sine 30 is the same as cosine of 60, and the result is 1 second, which is 1/2. Also, sine 60 is the same as cosine 30, and the result is 3/2. Sine 45 is the same as cot 45, and the result is simply 1/2. Tan 30 is equal to 1/3, and tan 60 is the reciprocal of tan 30, which is simply 3. And for the tan of 45, the result is simply 1. So these are the values for the special angles. If you want, you can have them copied down, and the other way, you can check out the video. In the video, I show the proof on how all these values are gotten. So this simply equals to, we said sine 45 is 1/2 times the cosine of 30 is 3/2 plus cos 45 is 1/2 times, okay, I'm using dots actually, the sine 30 is 1/2. Now at this point, you just need to simplify forward. So upon multiplying, 1 times 3 is 3, divided by 2/2, which is the product of 2 and √2, then plus 1 times 1, it gives us 1, and 2 times 2 is still 2/2. And if the LCM is 2/2, then we can have 3 plus 1. Now the next thing is to rationalize this fraction. Let's multiply the top and bottom. So you can either use √2 alone, that's fine, or use 2/2. Understand? But let's use √2/2. Okay. The main goal of rationalizing is to get rid of this radical that we are having at the denominator. So this eventually results in √2 times √3. That gives us √6. So we have √6. Then plus √2 times 1 gives us √2. Then we have division of 2√2 times √2 will simply be 2/4. And finally we have √6 plus √2 divided by √4 is 2. 2 times 2 is simply 4. So this is our final answer to this problem. And that's it. That's how to easily use some of this compound angle formula to solve problems involving trigonometry. So let's solve the second question, which is one of figure 2. So feel free to pause the video and figure it out yourself. The cosine of 75. So just like before, let's break 75 into 2 smaller angles, where those angles has to be acute. So that will be cosine of 45 plus 30. So now we can apply the compound angle formula. So cosine 45 plus 30 is the same thing as cosine 45 times cosine 30. Then since the sign is positive, for cosine it will be opposite. So we have minus sine 45 sine 30. So cos 45, we say the same thing as sine 45, which is 1/2, times cos 30, we said is 3/2, which is absolutely the same as sine 60. Then minus sine 45 is still 1/2, multiplied by sine 30 is 1/2. Simplifying this forward, we got 3/2 times √2 is 2/2, then minus 1 times 1 is 1, divided by 2 times √2, this gives us 2/2. So LCM can be 2/2, and we have 3 minus 1. So just like before, let's rationalize by multiplying the top and bottom by 2/2. So upon multiplying, we have 3 times √2, so gives us 6. Then negative 1 times √2, which gives us negative √2. Then we have division of 2/2 times √2 gives us 2/4. And finally, we have root 6 minus root 2 divided by 2 times 2, which is 4. And final answer in this case is also root 6 minus root 2 divided by 4. So this is also our final answer to question Roman figure 2. On to Roman figure 3, which is a tan of 75. So to find tan 75, just like before, we should break it in pieces into tan 45 plus 30. So according to the compound angle formula, tan 45 plus 30 is the same as tan 45 plus tan 30 divided by 1 minus tan 45 times tan 30. So for tan, the sign will still be the same for the numerator, but for the denominator, it will be opposite. Tan 45, we said is simply 1 plus tan 30, we said that's 1 over root 3. Let me write that properly. And divided by 1 minus tan 45 is still 1 times root 30. Sorry, tan 30, that's 1 over root 3. Amazing. So let's find the LCM of this. If we have 1 over 1 plus 1 over root 3, if the LCM is root 3, then 1 in root 3 gives us root 3 times 1 at the top gives us root 3. Then root 3 in root 3 is 1 times 1 at the top gives us 1. So we have plus 1. So this is the composition of this one. Alright? Perfect. So now we can have this. So for the numerator, we now have is to be equals to root 3 plus 1 over root 3. So now instead of this number line division, let me change it to regular division. So 1 times 1 over root 3 is theta. Now if we simplify this, we should get the same result, but the only difference will be that it will be minus that we have now. You understand? Because they were the same actually. The only sign that changes or that distinguishes them is just this plus and minus. Understand? If you find the LCM of these and try to compress it, you still end up having this value. So now if you flip it using the keep and flip, turn this upside down, then we can have multiply by root 3 divided by root 3 minus 1. So the root 3 cancels out, and we just left over with root 3 plus 1 divided by root 3 minus 1. And right now we can rationalize root 3 plus 1 over root 3 minus 1 times root 3 plus 1 over root 3 plus 1. Okay, perfect. So root 3 times root 3 gives us 3. Then root 3 times 1 gives us positive root 3. Again, 1 times root 3 gives us positive root 3. And finally, 1 times 1 for the numerator gives us plus 1. Then we have division. Root 3 times 3 again gives us 3. Then root 3 times 1, positive root 3. And negative 1 times root 3, negative root 3. And finally, negative 1 times 1 gives us negative 1. So we can simplify this more forward. We're almost there. So right now, we can have our result to becomes, now these are addable, we can add them, and we can also add the constant value 3 and 1. So we now have 4 plus 2 with 3 divided by, these cancels out, 3 minus 1 is simply 2. And if we factor out 2, we have 2 plus 3 divided by 2. Now the 2 can cancel, and left over is 2 plus 3. So that's our final answer to the tan of 75, which is the same thing as tan 45 plus 30. So by now I'm getting used to the techniques of using the compound angle to solve the trigonometric problem. So let's consider the last question for the Roman figure 4. Feel free to try it out, and after that you can pause it and see if you have done the right thing. So how can we simplify sine 120 minus 45? Well, notice that this question is the angle has already been broken into 2 pieces. But unfortunately, you can clearly see that Only one of this angle is a special angle, which is the 45. The 120 is not an acute, neither is it a special angle. So what can we do in this case? Well, this is when your knowledge in trigonometric ratio comes in. Understand? Now we know that the sine of 120 is the same thing as sine of 60, which is what you need already. You already get it. Now you might be wondering, how did I get this? That's why I said you need knowledge in trigonometric ratio. I'm also going to leave the link to my video on trigonometric ratio, which can be used as a reference to how all this answer is gotten. But let me show you why sine 120 is equal to sine 60. We know that if we have our quadrant this way, we know that in the first quadrant, all the trigonometric functions has positive sign. Second quadrant is sine, third quadrant is cos, and the fourth quadrant is third quadrant is tan, and the last quadrant is cosine. Now, sine 120 is not an acute, but if I want to measure this 120 on the quadrant, I will have to move starting from the positive axis. Then I move 120. 120 will exceed 90. So let's assume this is the 120. Now, what will be this angle? That will be 180 minus 120, which is 60. This angle and this angle, the result will be the same for sine. Why? Because sine is positive in the second quadrant, and 60 is at the second quadrant. So therefore, sine 120 is the same thing as sine 60. Assuming it is cosine now, then definitely cosine 120 would have been equal to negative cosine 60. Why? Because cosine is negative in the second quadrant. So that's how it works. So therefore, we are good to go. So like I said, you can always check out the video to aid your understanding. So this is the same as sine 120 cosine 45. Then the sign is minus, it doesn't change, minus cosine 120 times sine 45. Now sine 120 is the same thing as sine 60 multiplied by cosine 45, minus cosine 120 is the same thing as minus cosine 60 times sine 45. So this minus will affect this one, and we have the result to be equal to sine 60 cosine 45 plus cosine 60 sine 45. So right now, sine 60, we said is the same thing as cosine 30, which is equal to 3 over 2, times cos 45 is 1 over 2, plus cos 60 is the same thing as sine 30, which is 1 over 2, times sine 45, which is 1 over 2. So right now, on multiplying, we have root 3 times 1 to be root 3, over 2 times root 2 is 2 root 2. Then we have plus, let me do that again. 1 times 1 is still 1, 2 times root 2 is 2 root 2. From finding the LCM, we have 2 root 2 as the LCM, and we have the values at the denominator to be added together. So we have root 3 plus 1. So as we have been doing, let's multiply the top and bottom by root 2. And upon doing that, root 2 times root 3 gives us root 6, plus 1 times root 2 gives us root 3, also root 2. And we have divided by 2 root 2 times root 2. We have been doing this times with that number. We know that the result is simply 4. So this is our final answer to this problem. So that's it. I hope you find this helpful and understandable. So this is one way in which questions can come on the use of compound angle to solve trigonometric problem. Now, our next example right now, we will consider the other way in which questions can come. So let's move on to example number 2. If sine A is equal to 3 over 5 and the cosine of B is equal to 12 over 13, where A and B are both acute angles, evaluate without using table sine A minus B and cosine A plus B. So in your first sight, what do you think would be your first step in solving this kind of problem? Since you know that sine A minus B that you are required to find, according to the compound angle, is equal to sine A cosine B minus cosine A sine B. But unfortunately, only sine A is given. How can you find sine B? Similarly, cosine B is what is given. We don't have cosine A. How can we get it? So you can see that you are stuck at this point. Well, so this is what should be your first step. Your first step should be, since A and B are acute, then you can draw a triangle. Typically a right angle triangle. You know that the trigonometric functions connect the sides of a right angle triangle. If A is the acute and is somewhere around there, and the sine of A is given as 3/5. But you know that the sine of any function of a trigonometric function for an acute angle connects the opposite side with the hypotenuse side. This simply tells you that this 3 is the opposite side and this 5 is the hypotenuse side. So therefore, this will be 3 and this will be 5. But you know that you can always get the value of cosine A. Cos cosine A is equal to what? The adjacent A divided by the hypotenuse. So the goal is to find the adjacents. But you know Pythagoras theorem already. With Pythagoras theorem, you can always get the value of the side. So what's the Pythagoras theorem? If this is x, according to Pythagoras theorem, 5 squared, which is the hypotenuse squared, is equal to the opposite squared, 3 squared, plus the adjacent squared, x squared. 5 squared is 25, 3 squared is 9, plus x squared. Now, upon subtracting 9 from both sides, we have x squared to be equal to 25 minus 9, which is indeed equals to 16. And upon taking the root of both sides, the value of x will be equals to 4. So this is the adjacent. So therefore, cosine A will be equals to adjacent 4 divided by hypotenuse 5. Then you have cosine A. Then you repeat the same process for this angle. For B rather. B is also an acute angle. You draw another triangle for B. You are given the cosine B. Then you use to find sine B. And then you can proceed on substituting. So we have cosine A already as 4/5. Let's have it copied and shown. So cosine A is 4/5. So if you draw another triangle again, but this time around for angle B. So B is here. And we said the cosine function connects which side? The adjacent and the hypotenuse. And since cosine B, according to the problem, is 12/13, this clearly tells us that adjacent is 12 and hypotenuse is 13. So this is 13 and this is 12. So the goal is to find the opposite OPP. So keep in mind as well, opposite is the side facing the angle. It's very, very important for you to know that as well, in case you don't know. So now we can get the value of opposite using Pythagoras theorem. We know that 13 squared will be equals to opposite squared, OPP squared, plus 12 squared, adjacent squared. 13 squared is 169. Then the opposite squared is still what we are looking for. 12 squared is 144. So we subtract 144 from both sides, and we have 169 minus 144. This will gives us 25 equals OPP squared. Now, by taking the square root of both sides, OPP results in 5. So that is the opposite side. So therefore, sine B will clearly be equals to opposite 5 over hypotenuse 13. So that is sine B as well. Now that we have cosine A as sine B, we can proceed on solving our question. So sine B equals, what do we get? Over 5/13. Perfect. So we said this is the simplification. We can proceed on substituting. So sine A, we got that to be what? Is given as 3/5. So we have 3/5 times cosine B. We have that as what? 12/13. The minus cosine A, we have that to be 4/5 times sine B. We have 5/13. So we can multiply 3 times 12 give us 36. Divided by 5 times 13, that will give us 65. The minus 4 times 5 gives us 20. Divided by 5 times 13 gives us 65. LCM can become 65. 36 minus 20 gives us 16. So can we reduce? Not at all. Final answer is 16/65. So that's how to easily answer this kind of question as well. Without any further ado, let's consider the second question. Cosine A plus B. So the cosine of A plus B would be equal to the cosine of A, cosine of B, minus the sine of A, the sine of B. So we have everything already. The cosine of A, we have that to be 4/5 times the cosine of B is given as 12/13. The minus the sine of A, we have that to be what? 3/5. And the sine of B, we got that to be 5/13. We multiply again 4 times 12 gives us 24, 48 divided by 5 times 13 gives us 65. The minus 3 times 5 is 15 divided by 5 times 13 is 65 equals, so let's find the LCM is 65. Then we just subtract the numerator, 48 minus 15. 48 minus 15 will give us 33, and we have our final answer for the cosine of A plus B. So I hope you find this helpful and understandable. And I want to believe by now you should be able to handle any question involving the use of compound angle to solve trigonometric problem. Thank you once again. See you in the next video. Bye for now. So this is exercise. Feel free to share your solution with me via the comment section below.